VLSos here. This is a video lesson on an algebra technique or an algebraic strategy I call multiply through to help with complicated situations. Let's give an example of something that is fairly complicated. The equation 1/3 x squared plus x over 2 minus 1/3 is equal to 0. It's quadratic. It's got an x squared term. The coefficients are fractions. So if I use the quadratic formula, and I could, then I would be putting fractions into the quadratic formula, which is already complicated. We could do that. It would be challenging. So I'm going to deal with the fractions first. What I'm going to do is I'm going to take advantage of the truth in algebra that I can do anything to a side of an equation as long as I do the same thing to the other side. In fact, what I do to one side, I must do to the entirety of both sides. And the thing that I'm going to choose to do to the entirety of both sides, in this case, is multiply by 3. I'm going to multiply 3 through everything that I see. That means that this 1/3 x squared, when multiplied by 3, becomes just x squared. It's like we got rid of the fraction. X divided by 2 times 3 is still going to be the fraction, in this case 3x divided by 2. But the fraction 1/3 after I multiply by 3 is going to become simply just 1. And on the other side, since it's 0, 0 times 3 is 0. It remains quite simple. So I had 3 fractions, and I chose to multiply the entirety of both sides by 3, but I still have the fraction, 3x over 2. I could multiply through again by choosing to multiply both sides by 2. When I do, x squared times 2 becomes 2x squared. 3x divided by 2 times 2 takes care of that denominator, leaving 3x. And negative 1 times 2 is negative 2. Again, on the right, 0 times 2 remains 0. What I've done is I've converted the equation that I started with that had fractions into an equivalent equation that doesn't have fractions. And in this case, I haven't solved for x yet, but I've prepared my coefficients so that they're much easier to use in the quadratic formula. I could use the quadratic formula to finish up this problem. But my intention here is to show examples of multiplying through. So let's take another look. The equation 100x squared plus 100x equals 2000 is also quadratic. I could move the 2000 to the other side, and I would have coefficients of 100, 100, and negative 2000. If we're going to use numbers that large in the quadratic formula, then we're going to have a whole lot of places and big numbers to keep track of. So I'm going to multiply through by multiplying by 1/100th. I could think of that as division by 100, but we're calling it multiply through, so I'm thinking of dividing by 100 as multiplying by 1/100th. And when I do, and I do that to the entirety of both sides, 100x squared becomes just x squared. That's 100x squared divided by 100 is just x squared. 100x divided by 100 becomes just x. And 2000 times 1/100th, which is the same thing as 2000 divided by 100, becomes 20. I've created an equivalent quadratic equation, but the coefficients now are much easier to handle in the quadratic formula. So I could move forward and solve for x more easily after multiplying through. Let's have one more example. (4x squared plus 12 over x plus 9 is equal to 0. This is quadratic because it has an x squared term. But what are the coefficients? Not easy to tell. The variables are in the denominators. That's weird. So we're going to use the strategy of multiplying by through in order to change it into an equivalent quadratic equation where it's more obvious what our coefficients are to work with. In this case, I observe that I've got fractions. Variables are in the denominator. That's okay. We can multiply by x. We can multiply by a variable just as easily as a number. When I do, if I multiply the entirety of both sides by x, the right side is easy to take care of. 0 times x is 0. 4 divided by x squared times x means that one of the x's in the numerator will cancel one in the denominator, leaving 4 divided by x. Again, one of the x's in the denominator got canceled by the common factor in the numerator after we multiply by x. 12 divided by x times x will cancel the x in the numerator with the x in the denominator, leaving just 12. And 9 times x is 9x. I still have a fraction with a variable in the denominator. So I'm going to multiply through again by multiplying the entirety of both sides by x. Now when I take two steps like this, I don't have to. I could have chosen to multiply the entirety of both sides by x squared and done this in one step. But for the purposes of showing the results, I've separated into two steps. Let's finish. X divided by x times x leaves just 4. 12 times x is 12x. And 9x times x is 9x squared. On the right, 0 times x is still 0. Now we can see that we have a quadratic equation, but the coefficients are much more easy to find. The coefficients are 9, 12, and 4. Something that's relatively easy to put into the quadratic formula and continue to solve for x.